Hey everyone, in this lesson we are going to be continuing on with our next mini project. Now this one is going to focus on collision and collision detection inside of Godot. So in this mini project we are going to jump back to 3D and create a little skiing game where the player is basically being pulled down by gravity down this hill, and they are going to be using the left and right arrow keys in order to move, well, left and right to avoid the trees that we are going to place in the way. Now, if the player hits a tree, then that is going to restart the level. Okay, so collision detection is basically where we are detecting when two colliders have bumped into one another, and then we run a function on one of those objects. So what we're going to be learning is 3D physics, which is going to extend from what we learned in 2D physics, as well as collision detection, which is going to extend over to the scripting side. Alright, so inside of Godot, what I'm going to do is go ahead and create a brand new folder for this mini project. So I'm going to create a new folder here, and this one is going to be called Collision. Next, what we're going to do is create a new scene for our collision mini game. So I'm going to go up to Scene at the left, go New Scene, and since we are creating a 3D game, I'm going to create a new 3D scene. I'm going to rename the root node to be Main. And then I'm going to save this to our collision folder as collision.tscn. There we go. So if we open up that collision folder now, we should see that scene saved there. Now, with this game, we are going to be using a pre-made 3D model, which has a material and textures as well. The reason why is we might want to give our game a bit of flair with our own custom model. We already done that with the balloon popper, so let's do it again. Now, in the course files tab, there is a downloadable zip containing all of the assets for this course. Simply download that, extract the contents to your computer, and inside you should see a collision folder. Now, inside of Collision, there is a textures folder, which contains a color map, as well as a material and model file. This is basically all we need to have the 3D model, which is this 3D object file. The material basically defines how the texture is then applied to the model. So I'm going to select all three of these things and drag them into our project here. Okay, that's going to begin the import, and we should then see inside of our collision folder, we have a textures folder which has the color map PNG, and we then have our character female b.obj. Now, if I drag this in, just like with a Sprite 2D, it is going to create a new instance of Mesh Instance 3D, which is the node type that renders 3D models. And as you can see, here we have our 3D model with all of its texture applied. Now, this is a model from the kenny.nl website, which is a great resource if you want a bunch of free public domain assets for your game. So we'll be using this one. Now, before we start coding in everything from the player movement to the collision detection, we first of all need to build a bit of an appropriate environment. Okay, so I'm just going to delete this node right here. And by appropriate environment, I mean we need to create, first of all, a ski slope. And then some trees, as well as changing the background, because this doesn't really look like a skiing background now, does it? Okay, so what we're going to do is we're going to begin by creating ourselves a ground. And this is what we're going to have our player essentially ski down. So what I'm going to do is I'm going to create a brand new Mesh Instance 3D node. This one I'm going to rename to be Ground Model. And then what we're going to do is go over to the inspector, go over to mesh, and we are going to choose a mesh for our ground. Now, I'm going to choose box mesh right here, which is essentially going to be a cube. But what we're going to do is scale it and stretch it out. So if we go down to transform, what we can do is go down to the scale properties. And if I start changing the scale, you'll notice that all three axes get changed uniformly. Well, we don't want that. So I'm going to click on the little lock icon here to unlock each of these individual axes. I'm going to start by setting the Y to be 0.3, so it's a bit thinner. I am then going to set the X scale to be about 12, so we're going to have a width of 12. And then for the Z, this is going to be about 30. Okay, so this is basically how long our ski track is going to look. Next, we need to rotate our track so that we're going to actually have our player slide down it. So I'm going to make it about, let's just say minus 20 degrees, like so. And then what we're going to do is we need to attach a collider, because right now, if we were to press play and have our player in game, they would fall right through this model because there is no collider on this cube to actually make it a solid thing in the world. Right now, it is just a visual, essentially like a cloud. So what we're going to do is we need to make what is known as a static body 3D node. Now, a static body 3D basically acts as a solid object in our world. So I'm going to create a brand new static body 3D, and I'm going to click create. I'm going to call this one our ground. And then what I'm going to do is drag the model in as a child of ground. And we'll see that we have a little exclamation mark on ground, which is basically saying we need a collision shape in order for this to work. So as a child of ground, let's then create a collision shape 3D. And then basically we want to make this fit the bounds of the model. So I'm going to go over to shape. I'm going to make this a box shape 2D. And then if we click on box shape 3D, and if we click on that, we can then change the size. Now, I'm going to make this the exact same dimensions as our scale. So for the Y, I'm going to make that 0.3. For the X, I'm going to make that 12. And for the Z, I'm going to make that 30. Now, we simply just need to rotate this. So I'm going to rotate it. Let's open up transform and make sure the rotation is at that minus 20.3 that we had. Okay, and there we go. So now we should have this collision shape basically fit the bounds of this model. And if we zoom in, we should see that it is pretty much perfect. Okay, and there we go. So now if we were to have a solid object fall, it would hit this slope and slide down. Now, next up, let's add in a bit of a sky, because right now our sky is pretty bland. Well, in fact, I'm going to make it a bit blander, but we're going to make it fit the theme of it being cold. So what I'm going to do is create a new world environment node here. By default, it has that red background because we did change the clear color. I'm going to go over to the inspector, add a new environment to the environment property, then open it up, go over to background, change it from clear color to custom color. And then the color, we are going to make a nice blue, okay? It's a nice light blue, something like this. There we go. And I think that is all we're going to do for our world environment. You can, of course, go in and add in your own changes. But something else, and that is also a directional light. Now, at the moment, you can see that our mesh is lit, but this is only what we are seeing in this viewport here. If we were to press play, well, first of all, we wouldn't see anything because there's no camera. But if we were to add in a camera, this ground would be dark. So we actually need to add in a directional light as well. Let's then move it up. We then want to angle it down so it is actually pointing at our ski slope here. And then let's go down to shadow and enable shadows as well. So when we add in our character, let's drag them in, you can see they now have a shadow being drawn as well. We can then delete them again because we don't need them just yet. And that is our environment set up. Now, the only thing that is missing are the trees. As a bit of a challenge, I want you to go ahead and attempt to create the tree model. This is essentially going to be a cylinder combined with a number of different scaled spheres, and make that a child of a static body 3D node with a collider. And then as a bit of a bonus challenge, if you want, try and add materials to those models to make them look, for example, green for the leaves and brown for the trunk. Now that's quite a few steps, but see how far you can go in creating the tree. So I'll be right back to see how you're done. applied. Side of collision, extract the of a public domain. First of all, it's a branch. Now I'm going to choose transform, stretch. Let's just say minus 20 degrees. Like so. Display tube object, and we'll see that we need a collision solid. that object fall, it would hit this slope and slide through color shadow model. And try and add materials to those models to make them look, for example, green for the leaves and brown for the trunk. Now that's quite a few steps, but see how far you can go in creating the tree. Welcome back, everyone. So I hope you had a go at that challenge. Pretty much what we're going to do is we're going to start by creating ourselves a static body 3D node right here to represent our tree. And then what we're going to do is we are going to rename it to be tree, just like so. And now let's lay out the basic shape using different mesh instances. So as a child of tree, I'm going to create a new mesh instance 3D. This is, I'm going to call trunk, and I'm going to make this mesh of type cylinder mesh right here. Okay, down inside of transform, what we can do is I'm just going to bring this up so that the base of the tree, which is the origin down here, is going to be the tree trunk right there. There we go. And now what I'm going to do is just shrink down the sides a bit so it's not as thick. So for the scale, I'm going to set the X to be 0.75. Same thing for the Z. So you have a bit of a thinner tree right there. Now what we're going to do is create the leaves. Now for the leaves, I'm going to have a number of different circles. So another mesh instance. I'm going to rename this to leaves. And I'm going to make this a sphere. I'm going to move it up. I'm going to increase the scale a bit here, and then I'm going to shrink it down like that. All right, something like this. And then what I'm going to do is I am going to duplicate it, move it up a little bit, shrink that down a bit, duplicate it again, move it up, and then shrink that down as well. So now we have this sort of tiered tree look. And in fact, we can probably make the top sphere here a bit more circular just because it's at the top of the tree. Something like that. Now, if you wanted snow-capped tree leaves, you could probably leave it as is, but we're going to add in some materials now for the tree and for the trunk. So, down in the collision folder, I'm going to right-click and create a brand new resource, which is going to be of type material. But you can see there are many, many types of materials. We're going to go down to standard material 3D and create that. This one is going to be called tree_trunk. And then what we can do is drag it onto the trunk, and it should be applied like so. Next, we'll just double click on that tree trunk material, go over to the inspector where we have all of these settings. I'm going to go to albedo, and I'm going to change the color here to be a nice brown tree trunk color. Okay, so we can basically go through this, try and find the right color for that. I'm going to make it actually a bit brighter, just so it's a bit nicer to see. Something like this, I reckon. There we go. So we've got our tree trunk. Now we just need our leaves. So I'm going to create another material here. This is also going to be of type standard material 3D, and I'm going to call this one tree_leaves. We can then drag that onto each 3 of these little spheres here. Now, of course, if you do have a custom tree model that you want to use, you can, of course, use that one instead. But we are just looking at how we can sort of create models inside of Godot without necessarily having to import a model or use a modeling software, okay? You can create models inside of the engine. Although fairly simple, they do the job. And there we go. We have our little tree. Now, what we're going to do next is add a collider to our tree, because at the moment it just exists as a visual. So I'm going to right click on tree, add child node, create a collision shape 3D. And the collision shape for this one is, I'm just going to make it we'll make it a cylinder, and just make sure it fits the bounds of this tree trunk here. So we might want to decrease the radius a little bit, and there we go. So there we go, we have our tree, we have our collider. Next step is to save this tree as a scene, so then we can begin duplicating them and placing them around our track. So I'm going to drag tree into the collision folder, save that as tree.tscn, and there we go. Now what we can do is essentially just move this tree around our level here and begin duplicating it. So might have one there, might have another tree over here, move that over a little bit, might have another one down here. So yeah, just go through and begin placing in your trees. Okay, and there we go. So we now have our trees placed down on our level, ready to be dodged. Now, one more thing that we are going to do on our tree model that is going to be very important for later on is going to be adding what is known as a group to the tree. So if I open up my tree scene by just double clicking on it, what we're going to do is select the root node. Then over in the inspector, we're going to go to the top where we have the node panel right here, and then go over to the groups section. And here is where we can assign a new group to the tree. Now, what is a group? Well, essentially, a group acts as a way of tagging or categorizing scenes or nodes. So when we eventually detect collisions with our player, we want the player to know what they hit. Okay, if the player hits the ground, we don't want to restart the level. Only if the player hits a tree do they want to restart the level. But by default, the player doesn't know what a tree is, what the ground is. It sees them all as objects it is colliding with. So what we can do is put the tree in the tree group. So when we collide with it, we can go, okay, is this object in the tree group? If so, it's a tree and we should restart the level. So I'm going to click on the plus icon right here and give our group a name, which is just going to be tree, and click OK. Now you should see under scene groups, tree, and as a tick. So now this tree node, which contains the models and the collider, are a part of the tree group, and we can then detect that later in script. So in the next lesson, we are going to be looking at setting up our player object, which is going to be a thing that will fall and slip down the map right here. And then in a future lesson, we'll look at actually adding in a script to move left and right and detect collisions. So thanks for watching, and I'll see you. And I'm going to call this one that you want at least it fits the Now what we can do is essentially just move this tree around. Might have one there, another one down. There we go. Over to the groups section. So we're going to go to the top where we have the node panel right here, and then go over to the groups section. And here is where we can assign a new group to the tree. Now, what is a group? Well, essentially, a group acts as a way of tagging or categorizing scenes or nodes. So when we eventually detect, we don't want to reset, but by default, the player doesn't know what a tree is. With it, we can go, okay, on the plus icon. Now, you should see under scene groups, give our group a name, which is just going to be tree, and click OK. Now, you should see under scene groups, tree, and as a tick. So now this tree node, which contains the models and the collider, are a part of the tree group, and we can then detect that later in the map right here. And then in a future lesson, we'll look at actually detect. Welcome back, everyone. In this lesson, we are going to be setting up our player. So what we're going to do is create our player node using a rigid body node, because we want our player to basically fall and slide down this track here using physics. So what I'm going to do is I'm going to start by creating a new rigid body 3D node right here. Let's bring it up to the top of the track as well, and I'm going to rename it to be player. Now let's just move it up in the hierarchy here so it's at the top. We're then going to give our player its 3D model. So let's go over to the collision folder, drag in that 3D object like so, make that a child of player, rename it to, we'll go player model, and then we want to go to transform, set its position to be 0, and then we also want to rotate it to face the other direction. So I'm just going to rotate it around like that, and make its Y rotation 180. So there we go. We have our player and we have its model here. Now next up, let's add in an actual collider for our player so they can actually hit the ground, not just fall straight through it. So we'll add in a collision shape 3D. This is going to be, we'll make it a box, I reckon, just so the player doesn't start rolling. So we can then make it fit the bounds of them. It doesn't have to be too exact, it just has to be the rough shape of the player here. Okay, something like this. Move it up so that their feet are covered, and there we go. We'll make it actually a bit longer as well, since they'll be sliding down. We probably don't want them to flip over forward. And then we could also just move it back like that a bit as well. Now, before we press play and test it out, we actually need to attach a camera to our player. So I'm going to attach a camera 3D node to our player. And using the little preview window in the inspector, we can actually see what it looks like when we position it. So I'm going to put it here, tilt it down a little bit, something like that maybe. So now, if I press play, we should see that our player will fall and land on the ground. But they're not moving, they're not sliding down. Why is that? Well, the reason why is because by default, the physics settings are not set up to actually have the player slide, okay? Typically in the game, you don't really want your player sliding around on surfaces, so we don't have that enabled by default. So what we need to do is select our rigid body, and in the inspector you'll see there is a physics material override. Now, a physics material basically defines what the surface of the player is, okay? Is it rough? Is it smooth? Is it slippery? Is it bouncy? This is something we can set up here. So I'm going to create a new physics material, open that up, and what we need to do is go to where we have the friction setting, okay? So right now our friction is set to 1, meaning that this thing is not going to slide at all. So I'm going to bring this down to 0, which basically means that there is no friction at all. And if I save that, then press play, what you'll see is the player will fall and begin to slide. Okay, they'll hit the tree, slide around, and fall off the edge. So you can see how you can create some pretty interesting games using physics inside of Godot. Can try that again, and of course the exact same thing is going to happen because we have changed nothing of the starting parameters. But yeah, that is the physics working. Now, one more thing I am going to do is to just make our player have little skis, just because, well, they are skiing down a hill, so I think it is appropriate. So I'm just going to add in 2 mesh instances here for a ski. This is of course just going to be of type, where is it? Box mesh. We can then scale this down, stretch it out, shrink it down a little bit, and just make it fit the bounds of the player's feet. There we go. So we got 1 and 2. Now, if I press play, you can see that our player is now going down with some skis. Let's also then just add a color for that, but you know what we can do? We can actually recycle our existing colors. So I'm just going to make these some nice green skis here. Okay. And that's something you also should be doing in games, recycling materials, textures. It just saves on the amount of work that you have to do, and also saves on the amount of work that your computer has to do with loading in those resources. So now that we have our player set up, we need a way of actually moving them, because right now, as you can see, the keyboard arrows, we do nothing. We simply just keep going down this hill and bump into the tree and fall off the edge. So in the next lesson, we are going to be looking at creating our player movement script. Welcome back everyone. In this lesson, we are going to be setting up our player movement script. This is going to take in our keyboard arrows and allow us to move to the left or to the right. So what we're going to do now is select our player node, and then in the inspector, go right to the bottom where we have the script property. We're going to create a new script here. This one is going to be called player movement, and it's going to be inside our collision folder. So click create, and it's going to create that script right here. Now you can see it is extending from the rigid body 3D node, which we attached it to, meaning we have access to its variables and functions. So that is how we are going to actually move our player around, by modifying its linear velocity. Now, for this, we're going to create a variable called move speed of type float, which is essentially just going to be how much force we are going to apply to the left and to the right. So we want to also be able to change this in the editor or in the inspector. So I'm going to add the @export tag at the start so that it appears here in the inspector. Next, we are going to create the function called not process, but physics process. Now, physics process is a very similar function to process. Okay, process gets called every frame, and if you would actually put like a print line in here, you would see that physics process also gets called pretty much every frame, but there is a distinct difference, and that has to do with how physics in Godot works. The Godot physics engine works on a different, I guess you could say, system than the normal game loop. Okay, because when it comes to physics in games and in game engines, you want it to be consistent, okay? And to make it consistent, you want to update the physics objects and detect collisions at a set time rate per second. I believe Godot's is around 50 or 60 times per second, in which it detects physics and updates physics, whereas the process function gets called, it could get called 5 times a second, 100 times, 1,000 times a second. It will go up and down depending on your frame rate, but the physics engine runs on the exact same time step per second, and that is what the physics process function does. It runs at a fixed time step per second. So in here is where you basically want to do all of your physics update code. You shouldn't really be doing physics related code inside of the normal process function. It's general practice to do it inside of physics process. So in here, what we want to do is basically move left when we press the left arrow key and move right when we press the right arrow key. So what I'm going to do is I'm going to write if and then input dot is physical key pressed, and then we're going to search for key underscore left. Now, is physical key pressed is going to return true if the given key is being pressed this frame. So when we are holding down the left button, this is going to be true. And in fact, let's run a little print line of code here, which just says move left, just to see if it works. So I'm going to save that, press play. Now, if I hold down the left arrow key, you can see in the output that it is printing out those lines of code, which is great. Now, how do we actually get our player to move left? And what we want to do here is write down the function apply underscore force. Now, apply force, basically we give it a vector, and it is going to gradually push us in that direction at that speed. Okay, this is different than apply impulse, which is what we use in the previous mini project. Apply impulse is like if you're hitting a golf ball with a golf club. Apply force is if you're trying to push a very heavy object. So what we want to do now is basically give it a direction and then multiply it by our move speed. So the direction is going to be vector 3.left, which basically is -1 on the x-axis, 0 on the y, 0 on the z, and then multiply that by move speed so that we can have it go at a rate of 2. Now, when I press play, what you'll see is when I press it, we kind of spin off to the side, which is a bit strange. Now, the reason why that's happening is because we need to have a look at our setup here, okay? when we are applying this force, it is applying it from our rigid body's origin position right here. But you may notice before that we actually moved our collision shape over backwards a bit. And it's important to note that our collision shape is what defines the volume of our actual rigid body, not the models itself, okay? The collision shape is what defines the volume. Now, if we are pushing about 2/3 the way up in front of the model here, it's going to make it start spinning. It's going to turn it to the left and make it start spinning that way. So what we need to do is basically center our collision shape so that it is being pushed perfectly from the middle. So on the Z, I'm going to set that back to 0, so it's just like that. Now, if I save that and press play, you'll see that we now get a much more uniform push to the left. Okay, and finally, let's make it so we can push to the right as well. So here I will go elif input dot is physical key pressed key underscore right. Then we are going to go apply force, vector 3 dot right multiplied by move speed. And there we go. So now we can play that and we can move left and we can move right to dodge the trees. But again, it is pretty hard. So if I try that again, you can see we can dodge the trees, but we kind of got to time it all perfectly. And there we go. Now, in the next lesson, we are going to be looking at detecting collision with our trees, okay? Making it so that we can call a function when that event occurs, and then restarting the level. So thanks for watching, and I'll see you collision with our trees, okay? Welcome back, everyone. In this lesson, we are going to be setting up our collision detection with our trees. So in the previous lesson, we set up player movement so they can actually move left and right like so. Whoops, we started moving before we hit the ground. But now what we want to do is make it so that when we hit a tree, it is actually going to restart the level. So first of all, we need a way of actually having a function inside of our player script call when we hit a tree. So how can we do that? Well, what we're going to do is select our player. Then in the inspector, we're going to go up to the node panel, go over to the signals area, and inside of signals, we have a list of things here. Now, what is a signal? Well, you can think of a signal as like an event, okay? It is something that gets emitted when something happens. For example, in RigidBody 3D here, you can see we have the body entered signal, which basically means that this signal gets emitted whenever our character's collider enters another body, such as a static body, another rigid body, an area body, stuff like that. We have input events, we have mouse entered, so if our mouse enters the player's collider, that signal will be called. Visibility changed, if the visibility is toggled on or off, that signal gets called, and so on and so forth for all these other ones here. Now, what we are going to do is connect to the body entered signal, because when a signal gets emitted, it doesn't just emit into the void. What we can do is connect functions to signals. So we are going to have a function inside of our script that will be called when the body entered signal is emitted. Now to set this up, we're simply going to double click on body underscore entered. We are then going to select our player node, which contains the script, and select connect. Now what that's going to do is create a brand new function inside of our script here, and you'll see we have this little green icon basically telling us that this function is connected to a signal. So on body entered, like I said, this gets called when our collider enters the body of another, which is like a static body, meaning our ground, our trees. So let's actually see if it works. But before we actually write any code, we also need to go over this parameter. The parameter that gets sent over is body, and this is essentially going to be the other node that we hit. So what I'm going to do is I'm actually going to write a line of code here that is just going to print out the name of whatever node we hit. So I'll print body.name. Now, if I go ahead and press play, it should tell us when we hit a tree that we hit a tree, but not even the ground, okay? We hit the ground at the start of the game, we hit a tree, but there's nothing out here in the output. Why is that? Well, by default, our rigid body is not going to actually detect collisions in the sense that it calls it back through the signal and into the script. The reason why is because most of the time rigid bodies are just going to be used for things that bounce around the scene and collapsible bits of wood, stuff like that, and rocks, so we don't really need them interacting with the scripting side of things. And that saves on performance, but we do want this rigid body player to actually emit a signal. So to do this, we are going to select our player, and then down inside of the solver settings right here, we are going to enable contact monitor. This basically means that, as you can see, if true, the RigidBody 3D will emit signals when it collides with another body, which is exactly what we want. And also max contacts reported. This is essentially how many different contacts will be sent over in the signal. This is if you want to actually get into the nitty-gritty of collision detection. We don't really need to worry about this, so I'm just going to set it to be 1. Now, if I press play, you'll see that in the output it says ground, then tree, then ground, and we keep falling and hitting the tree, hitting the ground, and it keeps printing out to the console. So that's great, but what we now need to do is make it so that when we hit a tree, the scene restarts. But we don't want to restart when we hit the ground. We only want to restart when we hit a tree. Now, that is where that tree group comes into play. Remember, when creating the tree, we created the tree group. So what we can do is we can go if body.is in group, and we call this function, sending over the group name, which is tree. Then we can print restart level. Okay, let's see if that works. So I'll press play. As you can see, the ground, it said nothing, but if I hit the tree, it says restart level. As I'm on the ground, it doesn't say anything. Only when I hit a tree does it say restart level. But how do we actually restart the level? Well, what we have to do is call a function called reload current scene. So to do this, we first of all get the scene tree, and then we go dot reload current scene. And this right here is basically just going to reload the collision scene. So now if I press play, as you can see, if I hit a tree, it is going to reload the scene and allow us to keep on going down each time we hit a tree. So the collision detection is now working, which is great. But there is one little issue, and that is we are getting some errors down here in our debugger. So if I go over to errors, you'll see here we have these 4 errors. And the reason why this is occurring is something that's not necessarily our fault, but it's just something about how the Godot engine works, okay? We don't have to understand exactly why this is occurring, but basically we are trying to reload the scene when a collision detection has occurred, which has some issues in the sense that we can't actually unload an object before the physics frame has ended. So the way we can get around this is by calling the reload current scene function at the end of the frame rather than exactly when the collision occurs. So how do we do that? Well, we can do that by deferring the call. Deferring the call basically means we hold off on reloading the current scene at this current time, wait the very short amount of time before the frame has finished doing everything it needs to do, and then we call the function. So to do this, we are just going to go reload current scene and then go dot call underscore deferred. And this right here is going to defer that call so it gets called after the frame has run. And that should then solve the issue. So if I press play again and hit the tree, you should see down in our debugger, we no longer have any of those errors, which is great. Welcome back. Welcome back, everyone. We set up is actually when we hit a tree. So we're going to signals area, and inside of signals we have a list of things here. Now, what is a signal? Well, you can think of a signal as like an event, okay? It is something that gets emitted when something happens. Variable changed, just emit into the void. You have a simply going to end select. Select connect. Play is basically here is going to defer about how we go script here to have a function to our collider split. And we keep falling and hitting the tree, hitting the ground, and it keeps printing out to the console. If I hit a tree, it is going to reload the scene. And this right here is basically just going to reload the collision scene. So now if I press play, as you can see, if I hit a tree, it is going to reload the scene. Occurring is something that's not necessarily exactly what in a collision detector we can't actually the end of the collision. Well, we can do the hold on the thing it needs to do. We are just going to go, and this right here is going to defer that call. So play, remember, ground, then ground, I'm going to set it to be 1. Will be sent over in the signal. This is if you want to actually get into the nitty-gritty of collision detection. We don't really need to worry about because most of the time rigid bodies are just going to be used for things that bounce around the scene and saves on performance. And that saves on performance, but we do want this rigid body player to actually emit a signal. So to do this, we're going to select our player, and then down inside of the solver settings right here, we are going to enable contact monitor. This basically means that, as you can see, if true, the rigid body 3D will emit signals when it collides with another body, which is exactly what we want. And also max contacts reported. This is essentially how many different contacts will be sent over in the signal. This is if you want to actually get into the nitty gritty of collision. You'll see that underneath this is we can group. It says retrieve function. Hey everyone, in this lesson we are going to be looking at our next mini project, which is going to involve loops. So in this mini project, what we are essentially going to do is spawn a star, which is going to be a little texture on the screen, and randomize its position and its scale, okay? So every time we press play, that star can be in one position or another and change its size. Then we are going to do that hundreds of times to fill in the sky. Now, you may be thinking that is going to be a lot of code to write, but we are going to make this code a lot shorter than you're probably thinking that it's going to be right now, and that is going to be done via loops. So what are we going to learn in this mini project? We are going to learn about loops, how they work and how we can implement them. We're going to look at instantiating scenes, which is basically spawning in a new scene out of thin air, and then generating random numbers as well. So let's jump into Godot and begin setting this up. Okay, so to begin, what we're going to do is we're going to create a brand new folder for our loops mini project. I'm just going to call this one loops, and then we're going to create a new scene as well. Now, this is going to be a 2D scene, so I'm going to create a 2D scene here, rename the node to be main, and then save this to our loops folder as loops.tscn. And there we go. Now, the next step is going to be importing our star image that we're going to be using to represent the star. Now, in the course files tab, you can download the assets, extract them, and inside we have a loops folder. Now, inside of loops, we have a star PNG image. So I'm just going to drag that into our loops folder right here. There we go. And if I drag the star into our scene, then you can see that this is what it's going to look like. Now, if I go ahead and save and then play the scene, you should be able to see it right here in the corner. But we want to add in a camera to basically allow us to adjust the zoom. So what I'm going to do is I'm going to create a brand new camera 2D node. We've done this before already. Let's then go ahead and change the zoom to be about 2. Okay, so we're zooming in a little bit more. So now our star is going to look something like this. And there we go. We also might want to change the background because right now the background is red, which is not what we want. And it is red once again because of our clear color. Okay, remember the clear color is basically what color gets filled in with the pixels that aren't looking at anything. So what I'm going to do is go up to project settings, go down to rendering, then to environment, and change the default clear color to be black. And there we go. So now we have our nice black background where we can spawn our stars. Okay, but first of all, we need to actually create a scene that represents our star, because when we want to begin spawning in these stars via scripts, we need to actually have a scene that we can reference and make a copy of. So what I'm going to do is with this star node here, I'm just going to set its position to be 0, 0, and then I'm going to drag it into our loops folder and save it as star.tscn. Now, if we open it, that star sprite is now saved as a scene, okay? So we can duplicate it and use it as many times as we wish. Let's also then delete the existing star because we want to start with nothing at all. And now what we can do is go ahead and create the script. So I'm going to select our main script here, then go to the inspector, create a script, and call it loops. Okay, so inside of this script, what we want to do is start off simple. We just want to spawn in a star. So to do this, I'm going to create a variable called star scene. This is going to be of type packed scene. Now, packed scene is basically a scene that we have here in our file system, and this is going to be equal to preload. And then with the preload function, we just want to find that star scene right here. Now, what are we doing here? Well, basically, we are creating a variable which is going to reference this star scene we have just created. So then whenever we want to spawn it in, we simply spawn in the star scene variable. And preload essentially just loads the star into memory so that we don't have to do that later on when we need to begin using it, okay? We are preloading it. We are loading it into memory before it is needed. Now, the next step is going to be spawning in this star. So we're going to do that inside of the ready function, which gets called at the start of the game. So here I'll write func_ready, and ready is basically, again, this function gets called once when the main node is first initialized. So in here, if I write down print, spawn, and then press play, you should see that we have spawn written down here once. So that is where we are going to spawn the star. Now, how do we actually spawn the star? Well, what we're going to do is have a two-step process. First of all, we're going to create a variable called star, which is going to equal to the star scene dot instantiate. And the instantiate function basically gets this scene, and it essentially spawns it into our computer's memory. Now, if I press play, you'll notice that nothing happens. We don't actually see the star. And that is because even though this star now exists in memory, this new instance of a star exists in memory, it isn't actually inside of our scene, okay? It exists outside our scene waiting. So what we need to do is add this to our loops scene here. And to do that, we're going to call the add child function and send over the star. Add child basically means that this is going to add the star node that we just created to our scene here. So if I save that and then press play, you should see that the star is now visible right here, which is great. Okay, so we have that all set up. Now, in the next lesson, we are going to be looking at applying some randomness, such as shifting its position around randomly at the start of the game, as well as changing its scale. So thanks for watching, and I'll see you all then. just load the scene, the inspector as star times, and delete the existing star because we want to start with nothing at all. And now what we can do is go ahead and create the script. So I'm going to select our main script here, then go to the inspector, create a script, and call it loops. Okay. It's going to be spawning in this that nothing happens. This to see you all then. Welcome back, everyone. Let's look at adding in randomness to our star's position. Now, before we actually look at adding in randomness, we first of all need to define the bounds that our star can exist in. So if I drag the star scene in here and open up the transform dropdown, have a look at the position vector here, okay? So let's just say the furthest to the left we want our star to be is going to be around minus 280, and the most we want it to be to the right is going to be positive 280 pixels. So anywhere in between negative 280 and positive 280 along the x-axis is where our star can be. For the y-axis, that's going to be between between negative 150 and positive 150, okay? So anywhere between here on the y-axis. So that means if we pick a random x position between here and here, and a random y position between here and here, that means our star will be able to be placed anywhere within our screen here. So how can we do that? Well, let's start with just the x position. So what I'm going to do is I'm going to then get our star dot position dot x. So we're getting the star's x position equals rand f underscore range. Now rand f underscore range, we basically give it two values, a from and a to. It is going to return a random number between the from and the to. So the from is going to be minus 280 and the to is going to be positive 280, okay? Now, if we save that and press play, you should see at the start of the game, our star is going to have a new horizontal position each time. So it's over here, then if I press play again, it's going to be over here, okay? And that's because we are using randomness, okay? The randf underscore range function is very powerful. Now, let's also do the exact same thing for the y position. So we'll go star dot position dot y equals randf underscore range. Now for the y, we had minus 150 and 150. So if I save that and press play, we should see a random position somewhere on our screen each time we play the game. And as you can see, we are getting all of these random positions, which is really great. Okay, now next up, we want to give our star a distinct size, okay, because some stars are further away, some are closer, some are bigger, some are smaller, some appear brighter in the sky, so we're going to add a bit of randomness to our star's scale. So if I drag the star in here again, what we are now going to do is go to the star's transform scale here and basically modify this value, okay? So we are going to give it a random number between perhaps, let's just say 0.5 and positive 1. So 0.5 and 1. We're going to get a random number between these two right here. So let's go ahead and do that now. For this, what I'm going to do is, since we want the exact same scale to be on both axes, I'm going to create a little variable to hold the scale, and then we can apply it to both the x and the y. So here I'm going to go variable star scale equals around f underscore range between 0.5 and 1. Then what we're going to do is go star.scale.x equals star scale. So if I save that and press play, you should see that our star is going to look very distorted because I'm only modifying the horizontal size. But then if I go star.scale.y equals star scale, we should see that our star is now going to be scaled appropriately. There we go. It's a bit hard because we're not scaling by much. So if I go ahead and instead of 1 have 5, you'll see that each time you press play, the star is going to be very different size. So here it's this size. If I press play again, it's going to be smaller. It's going to be massive there, and it's going to be even massive there as well. Okay, so now that we have our star spawning in, it is working great. We need to add in about 200 more. So how do we do that? Well, we could just copy this code here, paste it in. We're going to get an error because we have the same variable name, so we could, change those around, something like this. Same thing for the star scale, do that, press play. Now we have 2 stars, but, our code is getting very convoluted, okay? We are duplicating the amount of code we have, and if we want to have 200 stars, we're going to have thousands of lines of code, which is not going to be nice at all. So what we are going to do in the next lesson is explore the concept of loops. Welcome back, everyone. In this lesson, we are going to be exploring the concept of loops. Now, we want a loop in the sense that we want to be able to run this code multiple times without having to write it out again. So what we're going to do is look at a loop, we're going to explore how it works, and then we're going to implement it into our code here. So for now, I'm just going to go above this code here in the ready function, and we're just going to work with printing stuff to the output just to see if it works. So a loop essentially encapsulates a chunk of code, and it runs that code however many times we define. Now, there are many types of loops, but we're going to just focus on for loops in this lesson. So to begin writing a for loop, we need to write for, and then we need to create a little temporary variable, which is basically going to be a number that will tick up by 1 after each iteration of the loop. And an iteration is essentially when you run the loop, that is an iteration. When you run the loop again, that is the next iteration, and so on and so forth. So I'm going to call this one I, and then we write in, and then we need to give it a number. Okay, so we can go, for example, 5. Then we could do a colon, go to a new line, and then we can print out, for example, run. Okay. So now if I go ahead and press play, what you'll see is that the message run gets run 5 times, okay, even though we only wrote it once. Now we can actually add whatever number we want here. So we could write, for example, 20 and press play, and you'll see that this gets called 20 times. You can see on the right-hand side here, 23 messages, including the top 3 lines at the top. Okay, so 20 messages. We could even add, for example, 20,000. Let's run that just to see what it looks like. It may take some time, but as you can see, yeah, we have not 20,000 messages, but 10,000, because I believe there is a cap for the amount that can be rendered in here. But yeah, as you can see, thousands and thousands of messages, just like that. And we only had to write the run print line once for that to work, which was amazing. So with for loops, we can essentially run code as much as we want without having to rewrite it, which is pretty great. So what I'm going to do now is I am going to go ahead and basically plug this code into the for loop by bringing it in line and then indenting it once. So select everything and press tab to indent, shift tab to undent. So it's indented in here. We don't want it to run 20,000 times. That will probably lag out our machine quite a lot. I'm going to write down 5 just for now. So let's see if we see 5 stars being drawn. And there we go. We have 5 stars in our game because this for loop is running this code 5 times. Now, this I that we see right here is a variable that ticks up by 1. Now, we aren't utilizing it. I say you mainly utilize this when working with arrays, but we're not going to get into that at the moment. Essentially, this I starts at 0, then it goes 1, 2, 3, 4, etc. until the for loop is done. So if I actually run a print line of code here that prints out I, what you'll see if I press play is it starts at 0, then it goes 1, 2, 3, 4. So it's basically telling us how many times this loop has run, and we can use that number for calculations as well. A pretty interesting one is if we actually have, let's just say 10 stars, what we can do is perhaps multiply the star scale by I. Okay, and if we do that, what do you think this is going to look like? Okay, I'm multiplying our star scale by I, which ticks up by 1 every single iteration of the loop. Well, it's going to look pretty crazy, I assume. And as you can see, each time we spawn in a star, the next star is going to get bigger and bigger and bigger and bigger. So that is essentially what we are doing here. But we don't really want that. We kind of want our stars to be consistent in size, but that is just something you can do. Now, what I'm going to do is have a variable that is going to control how many times we spawn in a star. So at the top here, I'm going to create a variable called spawn count of type int, and we'll make this equal to 200 by default. Now, I'm going to add the @export tag, so later on when we want to, we can just modify the number here inside of the inspector, okay? So we can save that, and then down here where we are defining the for loop, I'm going to replace 10 with that spawn count number. So if we press play, we will now have 200 stars in the snap of a finger spawned on screen. If we go back to our scene, we can change this number up to maybe 1,000. Oh, I think that's 10,000. We'll go 1,000, press play, and there we go. Now we can keep bumping this up. If we go maybe 10,000 now, you probably don't want to go too high depending on your computer, but this should be able to run fine. There we go. We have 10,000 stars now rendered on our screen. Now, of course, since these are just sprites, it's not going to be that performance impacting, but if these were enemies, for example, with their own AI, then yeah, you probably don't want 10,000 of them on screen at once. I'm going to bring this back to around 250 and just have a look at what that looks like. There we go. That looks nice. Nice little star system in the sky. We can change count, and then play. We will now have count number. So if congratulations on completing the course. We just finished looking at setting up 4 mini projects inside of the Godot engine. So our mini projects went as followed. We started with our balloon popper, which looked at us setting up the balloon model, the material, then being able to detect clicks on that balloon, increase its size, pop, and then we looked at script-to-script communication in order to basically up our score with every balloon we pop, and then afterwards add in a UI label to update the score text. We then looked at physics in a 2D scene by having our player jump around using the rigid body 2D node. So we were clicking on the screen, the player was then zipping towards that location, hitting boxes on their way, and just overall exploring the concepts of rigid bodies and physics inside of Godot. We then looked at that further in the third mini project, which looked at physics in a 3D scene, more specifically looking at collision detection. Okay, we had a player who was a rigid body slide down the hill. We then had the ability to move them left and right using arrow keys by adding a force, either left or adding a force to the right. And then when we hit the tree, we detected that collision and restarted the scene. And then finally, we looked at loops, okay, 4 loops in particular, which allowed us to basically spawn in as many stars as we wished without even changing the amount of code that was written, okay? And that's what's great about loops. You can do so much stuff without really adding any more code at all. Zenva is an online learning academy with over 1 million students. We feature a wide range of courses, for people just starting out or for those who just want to learn something new. The courses are also very versatile, allowing you to learn in really whatever way you want. You can choose to view the online video tutorials, read the included lesson summaries, or follow along with the instructor with included course files. So thank you very much for following along with the course, and I wish you the best of luck with your future Godot games.